Motion. Question 1. It says it is observed that a body performing simple harmonic motion SHM has a speed of 12 centimeters per second at a distance of 9 centimeters from the equilibrium position. Sometime later, increase to 15 centimeters per second at a distance of 5 centimeters from the equilibrium position. Take note of this from the equilibrium position. Those two statements. The distance from the equilibrium position is known as the displacement. So we have two speed, we have two what? Displacement. So let us have speed V1, take 12 centimeters per second as speed V1, 12 centimeters per second. Then the distance x1 as 9 centimeters. Sometime later increase to 15 centimeters per second. Take this as V2, which is 15 centimeters per second. Then at a distance of 5 centimeters, that is x2. x2 is 5 centimeters. I think you understand. So, all right. It says, what is the frequency of the motion? What will be the acceleration of the body at a distance of 8 centimeters from equilibrium position? When you see such question, what comes to your mind? This question is on simple harmonic motion, and we are giving V1 and V2 as velocity at instant. The first thing we do is to convert it to SI unit. So we have 9 divided by 100 is going to give you 0.09 meter. 12 centimeters per second. Let's convert it to meter per second. So it means we are going to convert the 12 centimeters only. 12 divided by 100, 0.12 meter per second. V2, 15 centimeters per second divided by 100 is 0.15 meter per second. Then 5 centimeters, that is what? 0.05 meter. You can see that's very simple. So to both of them, let's apply the formula for velocity at instant, which is V equals to the omega square root of a square minus what? Minus x square. So make use of this formula. So where your omega is angular frequency, where your a is amplitude. This one is amplitude. So where that x is displacement given as x1 and x2. So where this v is velocity at instant. So let's substitute all these parameters into that question. So we say that at displacement x1, what do we have? V is what? 0.12. You know we have converted. So equals to omega square roots of. Now what's our amplitude? It's not given. So what's our x? We are going to use x1, which is 0.09 all squared. So guys, let's take this as equation 1. Okay, so we are going to have at what? X2, that is our displacement x2. What's our v2? Our v2 is 0.15 equals to omega, yes, square root of amplitude a square minus what's our x? 0.05 all square. This is equation what? 2. So at this point, what should we do? Let us divide equation 2 by equation 1, or equation 1 by equation 2. Any one, we are still on the right track. Okay, so let's say divide equation 1 by equation 2. So this right hand side, left hand side divided by left hand side, right hand side divided by right hand side. So we are going to have what? 0.12 divided by 0.15, which is equals to omega, this one, abi, square root of what? A square minus 0.09 all square over, you can see this side divided by this side divided by this side. So square root of A square minus 0.05 all square. Okay, now guys, you can see omega cancel what? Omega. So if you try and press, this is 0.12 is 0.12 over 0.15 equals to the square root of A square minus 0.09 square over the square root of what? A squared minus 0.05 square. Okay, square root is common to both. Unlike when you have root A over root B, the alternative form of writing is what? Root A over B, collecting the common square root. So we have 0.12 over 0.15 equals to what? Collect a common root sum. A square minus what? 0.09 square over what? A square minus 0.05 all square. Okay, so at this point, what are we going to have? Now let's square both sides in order to eliminate this square root. Okay, square both what? Both sides. Okay, is 0.12 over 0.15 equals to square root of what? A square minus 0.09 all square over what? A square minus 0.05 all square. Okay, so we now say what? Square. Yeah, square. Yeah, square cancel what? Roots. Okay, so we are going to have 0.12 over 0.15 all square equals to what? A square minus 0.09 all square over A square minus 0.05 all square. So let's find this. What is 0.02 all square? 0.02 square is 0.02. Sorry, 0.12 and 0.12. We have 0.0144. Abi? So 0.15 is 0.15. That is 0.0225. Abi? So square A square minus what? 0.09 all square over what? A square minus 0.05 all square. So what should we do at this point? Let's square this. Also is 0.09 is 0.09. Okay, that is 0.0081. So let's square this also is 0.05 is 0.05 0.0025. So let's cross multiply at this point. Okay, let's cross multiply. We have 0.0225 bracket open A square minus 0.0081 equals to this one 0.0144 bracket what? A square minus 0.0025. Abi? So let's open the words bracket. Let me say clear the bracket. So to clear the brackets, we have to multiply through. So 0.025 times this, that is 0.0225 times this A square, that is A square minus So multiply 0.00 0.0225 times 0.0081. That is going to give us
0.000018225
equals to. So let's multiply this 0.0144a squared minus. Oh yeah, let's multiply that also. So 0.144 times 0.0025. So we have 0.000036. Okay. So what should we do now? Let's collect the like terms. Okay. Let's collect the like terms. So we are going to have 0.0225a squared. If this comes here, it becomes negative 0.0144 a squared equals to. Now if this one comes here, it becomes 0.0018225 minus 0.00036. You know it made this one here, so it has changed to plus. So let's add it together. So that will be okay. Sorry, we minus minus 0.000 18225. So this minus, you know this is bigger than this, Abi. So it's going to be positive. So we have 0.000014625. Abi. So yeah, this minus this, they are having a common
zero.
We factorize out a squared, then we subtract this
0.0081.
0.0225 minus 0.0144. Abi, you get 0.0081. Abi?
Yes.
0081 all squared. So let's make a squared the subject. A squared is going